This video will specifically show you how you would do a sample t-test for the Allium experiment, and we'll also address some of the challenges in doing the analysis this first time with this data set. So I've set up a page in my workbook that's called t-test calculations, and I'm going to build that page in a pretty generic way. So I've called things treatment 1 and treatment 2, because in a t-test you're comparing two average values. You can specify the names of those treatments, and then which phase of the cell cycle I'll be comparing, the average proportion of cells in that cycle, the counts, the variance, and then the t observed calculation will be in this column. And I'm going to enter that calculation now, beginning with an equal sign. And you calculate a t observed by taking the difference between the two means, so mean 1 minus mean 2, and it doesn't matter that I don't have anything in those cells right now, divided by the square root of the variance divided by n plus the variance of group 2 divided by n for group 2, and then I close my parentheses. And you'll see that this equation matches the equation that you are told to construct in the statistics chapter in your lab manual. So I hit enter, and Excel tells me you're asking me to divide by 0 because there's nothing in here. And that's okay. I don't need to worry about that right now. The way you're going to calculate degrees of freedom for a t-test is the sum of the counts, typed here, minus 2. And Excel says, okay, right now that's a value of 2. I don't know what my critical value is going to be yet, or conclusion, or my best P. That'll follow. But I do know that this general collection of information is the same information I want for all of my t-tests. And so I can copy it, and I can just paste it a bunch of times down below to know that I have it ready to go for my other equations. And then, as always, it's a good idea to double-click on your equation and make sure that Excel is doing what you want it to do. And it looks like it is doing what I want it to do. So now I'm going to go back to my working data because I want to get the information from here over to there. And I'm going to show you with one example. We'll look at a comparison between the control and the colchicine treatment, considering the proportion of cells that are in prophase. So back on my t-test page, I know I want to have the treatment name, the phase, the average, and the counts. And I'm going to copy those titles, and I'm just going to paste them in on this worksheet. So that's the information I want. And since my data is on this page, it's easier for me to collect my data on this page and then move it to the next page. And I'm going to show you a very simple way of doing that that will allow you to maintain a more fluid set of data without copy and paste errors. So the treatment name that I'm going to compare are colchicine and control. And I can either type those, or they're already typed in my page. So I can just say, I want the treatment name to equal the information you find in this cell. And when I hit enter, Excel does that. And the next one I want is immediately below that cell, relative, so I can just drag and fill. The phase of the cell cycle that I'm going to do is prophase. And again, I can drag and fill that. And then the average value, I'm going to say equal to this value, hit return. You've noticed the pattern that in this particular case, everything I'm doing is this row and then the row below. So I don't have to keep dragging and filling. I'm just going to fill in this top line by using my equal sign. And then I can highlight, in this case I can go back and if I want to, highlight all 4 of them and drag them down because the relative formula works for all of them. So I have all of my information in this one place. And I want to show you what happens when I try to move this information to the next page by copying and pasting it. So if I just highlight this information and I use Control or Command C to copy it, come back onto this page and use Control or Command V, it pastes it. And notice that there's kind of a problem here. All of my numbers have gone away. And the reason all of my numbers have gone away is that what Excel is seeing in this equation is some sort of a reference to a formula that no longer makes any sense to it. So there are a couple ways around this. One way is that I can paste special. Oops, I might go back, and come up to my paste and paste the values. And now the values are there. And now if I click on a cell, Excel doesn't ever show me the formula. It always has a value with way too many significant figures. The way I prefer to do it, however, is instead of copying and pasting, I'm going to use an equal sign again. So I'm going to fill in my table, start my table by saying, I want this cell to have the information equal that you find back on my working data sheet in that cell. And hit Control, hit Return. And now that information is here. It's referenced to my other page. I can drag over and I can drag down, and the data have been filled in. The important difference in doing it this way versus that way is if I figure out later on, darn, I have the wrong data in line 7, I can change line 7 over here, and that change will ripple through onto this page and into my statistical conclusions or calculations. So my preference is to enter my data this way. Now I have it over here and I can use it in my T calculation. So I want the same information, right? I'm going to just do the same equal thing. I want this information, and I want relatively all that information, and then I'm going to fill down. And voila, my t-value gets calculated. You'll see that in this case it comes up as a minus, and that's just because I subtracted the larger number from the smaller number. What you're going to ultimately compare in your t-observed and t-critical is the absolute value of the t-observed calculation. Now, in this particular value, I have 67 degrees of freedom. And if I bring over the table from your lab manual here, you'll see that 67 doesn't exist. I have 60 and 70. I'm going to move my line because the line I want to consider is the line that has the bigger numbers in it, so the degrees of freedom that are the smallest one near mine, and that would be the 60 line. And you would want to be comparing to the 0.05 value for the one-tailed or the two-tailed, and you need to make that assessment as to whether it's a one-tailed or a two-tailed. If you, with some good evidence, would predict a directional effect of a treatment, you may use a one-tailed test. If you don't have evidence to suggest a directional effect, then you would use a two-tailed test. And I think arguably in this experiment it's one-tailed comparison. So I need my t-critical to be greater than or equal to 1.671. I'm going to come back to my t-test here, and you see I'm going to put 1.671 over here. My t-observed value is considerably larger, and I conclude that there's a significant difference between those two means. I would like you to also calculate the best p. So if I come back to my table here, you can see that if I look all the way across, my value of 6 is still greater than the largest number in this row, which is 3.46. And 3.46 for a one-tailed test is a p of 0.0005. So I'm going to come back here and say my best p-value is 0.005. What that means is that there is a strongly significant difference between the colchicine and the control treatments with regard to the number of cells in prophase. In this particular data set, which again I want to stress is not the actual data set you guys are analyzing, it's an earlier version of it. So now you have a sense of how to move data rather than copying and pasting, how to reference things that will allow errors and calculations to ripple through, and how to do a t calculation. And you're going to want to be presenting all of your t calculations in your worksheet.